All right, in this video we're going to talk about quadratic inequalities, and we're going to also be reviewing interval notation. It's how you would solve or state your solution to an inequality. Now remember, a quadratic equation is an equation that has a power of 2. So an inequality means we're going to have a power of 2 as well when you have a quadratic inequality. So we want to solve this and express the solution in interval notation. So it's you got the 0 on the right side by itself. That's exactly like the form we want this to be in when we're trying to solve it. So in this case, hopefully we can factor or use the quadratic formula on the quadratic equation. In this one, it's going to be pretty easy to factor, I believe. So two numbers that multiply to give me negative 54, that add to give me 3. So that should be plus 9 and negative 6, I believe. Now, the points where you actually would be equal to 0 would be at negative 9 and positive 6. So let's talk about that for just a second. On the number line, negative 9, positive 6. Those are kind of like critical numbers. Those are the numbers where you're actually equal to 0. But we don't want to know where we're equal to 0. We want to know where our inequality would be less than 0. So once you plot those critical numbers on your number line, you need some testing points to work with on your number line. So I'm going to use a different color here to show the test points. You've got 3 intervals. We have the interval in the problem from negative infinity up to negative 9, the interval between negative 9 and 6, and the interval greater than 6, so 6 to positive infinity. So any number in this interval, you could use a test point for this interval. So since that's negative 9, I'm going to use negative 10. Any number between negative 9 and 6, I'll use something easy. So how about 0? And then any number in this interval, so I'll use something bigger than 6, like 7. Okay? You're going to take those test points and you're going to test them in your original quadratic polynomial there. So I'm going to take the negative 10 and I'm going to plug it in to x squared plus 3x minus 54. So if I do negative 10 that way, that's going to give me 100 minus 30, so that would give 70. And then 70 minus 54 would still be a positive number. So this interval we're going to say is positive. All test points in this interval would give me a positive answer. So check the next interval. If I check the test point 0, 0 plus 0, so that's 0, minus 54, so that's negative. We get negative in that interval. And then the last interval, we're going to test the 7. So let's see what we get here. 49. I'm going to run this through my calculator. 49 plus 21 minus 54, and I got a positive value. So this interval is positive as well. So go back to your original statement, and it says, where is this polynomial less than 0? Less than 0 actually means negative. If it's less than 0, it means negative. Where is it negative? Well, it looks like the interval where this inequality, this polynomial would be less than 0 is between negative 9 and positive 6. So that interval, we're not going to include the endpoints because notice this doesn't have the little equal to mark underneath it. If you had that line underneath that means equal to, we would include these endpoints. But in this case, these are not included endpoints. So we use parentheses. So our interval solution is from negative 9 to positive 6. So that's in parentheses. Comma separates the endpoints of the interval from negative 9 to positive 6. Any number in between these two numbers would make this a true statement. Okay, let's try another one. Solve 4x squared minus x minus 14 is less than or equal to 0, and express the solution in interval notation. So same thing we were doing. So hopefully we can factor this problem. I'm going to try. So the 4x squared, we could try, How about 4x and 1x? And for 14, we could do 7 and 2. I believe that will work right here. 7 and 2. The outer would be 8, and the inner would be 7, so I can get the negative 1. So we need negative 2, positive 7. Let's make sure that works. 4x squared minus 8x plus 7x is negative x in the middle, and then 7 times negative 2 would be 14. So those two solutions, if we were to set those equal to 0, the critical numbers will end up being negative 7/4 and then positive 2 on down the line here somewhere. So again, I have 3 different intervals on my number line to test. Negative 7/4 is like negative 1 3/4. So I could pick negative 2 as a test point. Something between negative 7/4 and 2, I could pick 0 as a test point. And something larger than 2, I could pick 3 as a test point. So we're going to test those in this polynomial and see what signs we get. So if I try negative 2, that would give me 4 times 4, so 16. Minus negative 2, so that's going to be plus 2. Minus 14 gives me a positive number, so this interval is positive. If I try to plug in the 0, I would get 0 minus 0, so that's 0 minus 14 gives me a negative. Then if I try 3, 3 squared is 9, so 4 times 9 would be 36. Minus 3 minus 14, which tells me that's going to be a positive number as well. Now look at your original problem. You do have the mark underneath, the equal to mark. Where is this polynomial less than or equal to 0? So the endpoints, we want to know where it's equal to 0. So the endpoints are included this time. And the interval where we're negative, less than 0, it means negative. Okay, so since it's negative between negative 7/4 and 2, my interval notation is going to be brackets this time. Excuse my pen's going crazy here. But it should be brackets. And the brackets are there because we are equal to the endpoints. If you have the little mark underneath, the brackets, that's from it being equal to those numbers. So everything between those, including those endpoints, that is our solution. Let's try one more. And the nice thing about this problem is we're already in factored form. That's kind of nice. But notice you have one of your factors that's to the second power. That's going to be interesting in how we do this. So my critical points will be easy to find. X plus 1, if I set that equal to 0, I get negative 1. And then x minus 3, if you set that equal to 0, you get positive 3. So those are our critical points on the number line this time. So negative 1, positive 3. We can pick a test point in each interval. So I'll pick negative 2. How about 0 and positive 4? See what happens. Now here's the cool thing. If a factor is being squared, we know it's always positive. So this one's not going to have any effect on the sign of the inequality ever in the test point. This will be positive no matter what I plug into it, because when I square the quantity, it will always be positive. So really the only thing I have to check here is this x plus 1 factor. So if we plug negative 2 into that, negative 2 plus 1 gives me a negative, so that's going to be negative in that interval. 0, if I plug 0 in, that gives me a positive 1. And if I plugged in 4, that gives me positive as well. So in this case, we want to know where this expression was greater than 0. So where is it positive? Well, it's positive from negative 1 all the way to infinity. So and it's not equal to 0, so we want to not include any endpoints. So we're talking about, if we don't include that endpoint, we have to do all this way. So let's say the interval notation on this will be interesting. It will be from negative 1, comma, up to 3. And I can't include the 3 in my solution, so we're going to have a union. We're going to have a break here. I'll pick up at 3 to infinity. Because 3 makes it equal to 0, and we don't want it to ever be equal to 0. We just want to know what numbers will make it greater than 0. So here's my interval notation. Okay?